Hi guys, this is Mrs. Scott. Here's your bad joke of the day before we get into the lesson. What is the best way to use debate? Well, you gotta put it on the hook. See, this sounds like the bait if you're fishing. Anyone that's ever fished probably thinks this is funny. Or maybe not, I don't know. So, let's look at our essential question for today. So by the end of this video, you should be able to figure out what are the 5 different relationships between perpendicular lines. Well, the first one is in Theorem 3.8, which says if 2 lines intersect to form a linear pair of congruent angles, so say that we have these 2 lines forming a linear pair of congruent angles, that means these both have to be 90 degrees, meaning the 2 lines are perpendicular. Okay. Theorem 3.9 tells us that if 2 lines are perpendicular, so say we know this line is perpendicular to this line, then they intersect to form all of these 90-degree angles, which is 4 right angles. Theorem 3.10 tells us that if 2 sides of 2 adjacent acute angles are perpendicular, so say we have this and this are perpendicular, and it makes these 2 acute adjacent angles. So if we say this is angle 1 and angle 2, we know that if these lines here and here are perpendicular, it makes 90 degrees. So then those 2 acute angles have to be complementary. Let's remember, complementary means they add up to 90 degrees. All right, the last 2 theorems are kind of tricky, but they're actually the most useful to us. So we got to take these and look at them carefully here. Theorem 3.11 says if a transversal is perpendicular to one of 2 parallel lines, then it is perpendicular to the other line. So let's look at that. So say we have these 2 parallel lines. So let's put arrows on them to show that. And if a transversal is perpendicular to one of the 2 parallel lines, I'm going to put the then in a different color here, then it's perpendicular to the other line. So everything that is in pink is what we start with. The conclusion is this right here that I'm highlighting, then it's perpendicular to the line, the other parallel line. Okay? The last theorem says if in a plane, if 2 lines are perpendicular to the same line, then they are parallel. Oops, better not use a highlighter here. They are parallel to each other. So let's look at that with a picture. So say we have 2 lines. So here's a line, and here's another line. And if they're perpendicular to the same line, so say we know they're perpendicular to that line there, then what we're going to conclude is they're parallel to each other. So this highlighted portion is the conclusion. All right. So now let's put those theorems into action with some examples here. The first 3 examples, we're going to figure out which theorem justifies the statement. Well, in example 1, these arcs mean that angle 1 is congruent to angle 2. So then we're concluding J and K are parallel. Well, theorem 3.8 tells us that if 2 lines are intersect to form a linear pair of congruent angles, that's what we have, then the 2 lines are perpendicular. So we are using theorem 3.8. Okay. 2 says that angles 4 and 5 are complementary. Well, if the 2 sides of 2 adjacent acute angles are perpendicular, then they're complementary. That is using theorem 3.10. All right, next, angle 1 and angle 2 are right angles. Well, I notice these 2 lines are perpendicular. So if two lines are perpendicular, then they intersect to form 4 right angles. So we know all of those angles would be 90 degrees or right angles. That's theorem 3.9. Okay, the next examples are pretty similar. So we're going to explain how we would show that M is parallel to N. Well, if you look at example 4, line T is perpendicular to both of those lines. So if you look at our last theorem, if two lines are perpendicular to the same line, then they are parallel to each other. So we would say, by theorem 3.12, line M is parallel to line N because they're perpendicular to the same line. All right, 5 is going to be a little bit trickier because we actually have to use 2 theorems here. Notice that this is x degrees and this is x degrees. So those two are congruent and they're a linear pair. So if they're congruent and they form a linear pair, those two lines must be perpendicular. That's theorem 3.8. That's the first thing we have to say. So by theorem 3.8, we know that T is perpendicular to N. So that means this would be a right angle right here. Then we can use that same theorem as last time. Since that line T is perpendicular to M and N, so the two lines are perpendicular to the same line, those two lines would have to be parallel. All right, one more example here. Notice that this is 90 degrees. Well, I know this is a linear pair, so they have to add up to 180. So the only way we could do that would be is if this x was 90 degrees. Well, if x is 90 degrees, that means this is a right angle here. So again, we can say by theorem 3.12, these two lines are perpendicular to line T, the same line. M is parallel to N then. Okay. So let's kind of switch gears a little bit here, flip to the next page. And we are going to explain why the statement in the figure is incorrect. Well, they're saying here that line Y and Z are parallel. But unfortunately, we don't know if Y and X are perpendicular. So this is incorrect because we don't know if Y is perpendicular to X. In that case, we can't say that Y is parallel to Z. Okay, I know it looks like this is a right angle here, but unless they actually put that box in the corner, we can't say they're perpendicular, so they're not perpendicular to the same line. Therefore, we have no idea of saying these are parallel or not. Okay, let's look at example 8. So they tell us that in this diagram, line FG is perpendicular to line GH. If that's the case, then this has to be a right angle, and we know that those have to add up to 90 degrees. Then we can say 2x minus 9 plus x equals 90 degrees, and from here we can just use algebra to solve. So first thing, I'm going to combine like terms, giving me 3x minus 9 equals 90. Go ahead and add 9 to both sides, and we end up with 3x equals 99. And if we divide by 3, x is 33. And in the directions, it just says to find the value of x, so we don't have to go and plug it back in anywhere for this particular problem. Okay, one more example. It says to use the diagram below to answer the question in number 9. If you answer yes, which theorem allows you to conclude that the two lines are parallel? So first of all, we're going to ask ourselves, is R parallel to S? So if we look at R and S, we would have to have those two lines perpendicular to the same line. And they're actually perpendicular to different lines. R is perpendicular to M, S is perpendicular to N. So since they're not perpendicular to the same line, we can't conclude if they're parallel or not. So there's no way of us knowing that. Okay, let's look at another example here. Is M parallel to N? So I'm going to highlight M and N here. And again, they have to be perpendicular to the same line. So M is perpendicular to T and R, but N is only perpendicular to S. So since they're not perpendicular to the same line, again, we have no way of saying if they're parallel. All right, lastly, is R parallel to T? Well, here's R and here's T. And now notice in this case, they're both perpendicular to line M. So since they're both perpendicular to the same line, we can say that they are parallel. And that was that very last theorem, theorem 3.12.